Hello everybody, my name is Nicola Brambilla, I'm the CTO at Fastcaps Systems, and today we will be talking about Fastcaps technology, and in particular we'll focus on what is a supercapacitor. So a supercapacitor looks like this, okay, so you see it looks like a battery, okay, so we have different form factors. We have a AA cell, we have what we call D cell, okay, we also have smaller form factor like this flat cell, okay. And so these devices are energy storage devices, which means that we can put some electric energy into this device, and we're able also to take it out. So we can charge and we can discharge. So it looks like a battery, but the main difference is that we can do that much faster. So if you want to charge a battery or if you want to discharge a battery, that usually takes, I don't know, half an hour, 1 hour, and you can experience that with your cell phone, for example. With these devices, you can do that in a fraction of a second, so it's very fast. And it can deliver very high power for a very short time. Also, the other main difference is that you can charge and discharge them for many thousand times, up to a few million times actually. And this is another big difference between a supercapacitor and a battery. So now, what is inside these packages? And it's what I have here on the board. So a supercapacitor is mainly composed by three different things. We have the electrodes, okay? Those are these black guys here. We have the electrolyte, and we have the separator. So the electrodes look like carbon sheets, okay? But they're extremely porous. They have a very high surface area. They look like sponges if you look at the microscope. And here, I draw them as a lot of spikes and pores. And you have the electrolyte that is a liquid with many ions in it, right? So we have positive ions and we have negative ions that are all in this liquid. We also have the separator, and the separator is like a membrane. It's a porous membrane, so that the electrolyte can go through the membrane, okay? But it prevents the two electrodes from touching and from creating a short circuit when we apply a voltage. So what happens when we apply a voltage? So when we apply, for example, a 3 volt here, we are charging the device, meaning, we have positive ions and negative ions start moving towards the electrode having an opposite charge. So for example, the positive ions will move toward the negative electrode, and the negative ions will move toward the positive electrode, okay? When we do that, we are storing energy into the electric field that is created within these two electrodes, okay? So this is the main difference between a supercapacitor and a battery, meaning the supercapacitor can store this energy in the field, whereas in the battery we store the energy through some electrochemical processes. And this is why we can do that very fast, okay? To give you an idea on how fast we can do that, so we can charge the capacitor in a few milliseconds, okay? So it's extremely fast. So now, how do we go from here to these devices, okay? So you need to imagine that this is like that those two components, basically the electrodes and the electrolyte, are like sheets, okay? And you can wind them, okay? And then you can put them inside this cylindrical package, and then this package is completely sealed. So now, what is the difference, the main difference between our supercapacitors and other supercapacitors that you can find on the market today? And this is extremely important. So the main point is the temperature, okay? So we are able to have these devices working very well at 150 degrees Celsius. So this is more than double the operating temperature of our other competitors. So either we do that, or we also have extremely long lifetime, so more than 5 years at 70 degrees Celsius. And those are extremely important for different types of applications, like, for example, defense application, oil and gas application, also, for example, the aerospace application, SSD applications, there are many. So we're able to survive this high temperature and also very high value of shocks and also for vibration. So if we drop this device like this, okay, so this is going to be able to work afterwards. And this is because we engineered inside this cell a proper mechanism that is able to make this device make it work with like up to 200 G shock. The other point that I wanted to mention today is about this carbon. So before I only said that this is porous carbon, but it's not just porous carbon. This is one of our core technology that we have. We use something that is called carbon nanotubes. So carbon nanotubes that they look like those guys there. I call them CNTs. That's how we used to call them. They are very tiny filaments of carbon that are extremely electrically conductive. They can be as long as 1 millimeter. Okay, so you can actually see them. But the diameter of these nanotubes is extremely small. It's less than 10 nanometers. When I say 10 nanometers is equal to 10 to the minus 8 meters. So it's something that you can only see with some very sophisticated microscopes. So we are able to introduce these nanomaterials that have a lot of surface area, because if you think that in a centimeter square you have like billions of these nanotubes, and if you look at the microscope, you have a lot of pores that are very small, and all these ions are able to go inside these pores. So this is what really creates the high surface area here, and as you can see, the capacitance value, is actually, it scales with the surface area. So the more, the higher is the surface area, the higher is your capacitance, and the higher is also the energy. So that's all we care about supercapacitors. We want to have a high energy and also high power, meaning we want to deliver this energy very quick, very fast. Okay. So we were able during these past 7 years to basically engineer this electron and mix these carbon nanotubes with other nanocarbons, and this mixture is basically is creating a very high surface area and extremely highly conductive electrode material. The electrolyte is also another very important component. The types of electrolyte we use are stable at very high temperature, up to like probably 400 degrees C. They can actually survive. So this is a very important thing. So I hope I gave you like most of the, probably the most important aspects of our technology about the single cell. Then obviously we not only sell the supercapacitor, we are able to sell also the systems, which means that we can connect multiple of these cells in series or multiple of these cells in parallel, okay? Because the customer not only wants 3 volts, perhaps wants 100 volts, okay? So you need to be able to connect these things in series so that you can get to the voltage you need. And I think that's probably all for today. If you have any other questions, please ask me and I'll be happy to answer.